Okay, so what is that curve we get when we have a quadratic? Parabola. Okay, a parabola. The graph is a geometric representation of the algebraic function. If a is greater than 0, and that means positive, the parabola opens up. If a is less than 0, which in your mind you want to think negative, then the parabola opens down, right? The vertex can also be called what? It's that top or bottom, so we call it a max or a min, right? If it's shaped like this, that's a maximum. There's a minimum, okay? The axis of symmetry is an imaginary vertical line of symmetry passing through the vertex and perpendicular to the x-axis. We are studying quadratic functions right now, so we're only talking about quadratics that open up or down, parabolas that open up or down. Later, when we get to conic sections, we can talk about ones that open side to side, but those aren't functions, correct? So when you think about a parabola, right, there's your max or your min, and you've got an axis of symmetry going through it. So for us, that's going to be perpendicular to the x-axis. Now, how you find it is x, the x part of the vertex, right? Because the vertex has an xy point. The x is negative b over 2a, which sounds very familiar to you. Remember, and when we talk about all these a's, b's, and c's, remember the equation is ax squared plus bx plus c. So a is the term with the quadratic, b is the term with the linear, and c is your constant term, right? So that's where all the a, b, and c comes from. The place on the graph where the quadratic function crosses the x-axis is called an intercept. These are written as number 0, like 5, 0, negative 3, 0. They're always real numbers. A number at which the polynomial is equal to 0 is called a 0 or a root, right? Or a solution. Any of those words would work. These can be written as x equals, like x equals 5, x equals 7, whatever that is. And they can be real or imaginary. For a polynomial, for a quadratic, we always have 2 zeros. They may be real or imaginary. Where you see them cross the x-intercept, that's where they are intercepts, okay? So let's make sure that that vocab makes sense. A lot of times people like to interchange these words, and intercept is a little more special. It's a location, right? It's like an address. So sketch the situations where there are no x-intercept, 2 roots. Well, that would be something like this, right? It never crosses the x-axis, but it has 2 roots because they all do, because it's squared. What kind of roots are they? They're imaginary roots. Are there zeros? Yes. There's 2 imaginary zeros. Let's see if we can draw one x-intercept double root. Well, that means it's on the axis, right? So it just touches in one point. We call that a double root. Are there zeros? Yes. What would the equation of a double root look like? Like I put an intercept at 4. What that means is when you had the equation, you had x minus 4 times x minus 4, which was x minus 4 squared, right? Okay, so that's where that came from. I'm kind of foreshadowing. This number is going to be really important. So you've seen that square, you've seen it there. There's a reason for that. 2x intercepts 2 roots. Well, I can draw any parabola, right? I have 2x intercepts. They're right there. Are there zeros? Yes. 2 of them, right? 2 real. So, and these, of course, could be pointing upside down or anywhere you want to draw them. The big thing to notice is that if you see a parabola up in the sky, or even if it were down here, then you know the roots are imaginary. What does it tell you about the quadratic formula? The number underneath the square root is going to be negative, right? You're going to get an I, get some I's in those answers. Okay. 3 forms of a parabola that we need to know. We're going to talk about a couple of them today. Standard form. And you may see standard and vertex switched in some places where you look, some authors. Sometimes you'll see this called the general form. Our text calls it standard form, so that's what we're going to call it. So this is just, you know, 3x squared plus 7x plus 12, whatever. It has numbers. A is not equal to 0. Now you can always find the vertex without stressing out. All you have to do is what negative b over 2a. So that's this number over 2a. Once you find the x value, you can plug it back into the equation to find the y value, and you found the vertex. A tells us, which you know from our previous unit, A tells us if we have a vertical stretch or shrink. If A is bigger than 1, and I don't mean the sign, I mean the digit itself, like 2, 3, 4, or 3 halves. If it's bigger than 1, we become narrowed because we're stretching, we're pulling. If A is small, 1/2, 3/4, 2/3, a fraction, then we're getting wider, right? It's going to widen your graph, and you want to know that. Vertex form, f of x equals a times x minus h plus k, where hk is the vertex. That's a nice form because you can immediately read the vertex. That's very handy. Intercept form means it's factored, like x minus 3 times x minus 7. There can still be an a out front, right? And as we work through these, you'll see there's advantages to having a certain form in certain situations. If I want to know the intercepts, this one's better. If I want to know the y-intercept, then this one's easy because C is your y-intercept. If I want the vertex, this one is better. So they all have a reason to be there, right? All right, we're going to practice with a couple of them today. Then we'll take time and practice, and then we'll finish quadratics next time. So let's graph the following and find all of its unique characteristics. So no matter what equation you're given, we want to be able to find everything. We want to know everything there is to know. So what direction does this open? Up or down would be your answer. This opens up. Why does this open up? Let's answer the whys so you remember. A is greater than 0, right? A is right here. Since there's no number there, what is A this time? 1, right? But it is positive, okay? If it opens up, immediately put this picture in your head. We know it's going to look something like that. Now we can answer the question, is the vertex a max or a min? The vertex is what? A minimum. They want us to find that. How do I find the vertex? I can just read it. It's in vertex form, right? Remember, it's x minus h, so that h is positive, so it's, if it were x plus 2, that means it was x minus negative 2. That's when your h would be negative, right? When your vertex would be negative. So it's kind of backwards from what you'd think. X-intercepts. How am I going to find the x-intercepts? Well, since I have the vertex in A, one way I can graph it and see if they're integers, right? If they're decimals, I may have to do some other work, but let's see how easy it is to graph. I know my vertex is at 2, -4. Now this is a squaring function, correct? And a is 1, so it's not stretched. So if I go over 1, this is a squaring function. I square 1. What's 1 squared? 1. I go over 1, I go up 1. Now, if I go over 2, 1, 2, what's 2 squared? 4, so I should count up 4. And of course, it's a mirror image. If I start at the vertex and I count over 3, 1, 2, 3, how far up should I go? 9, because it's a squaring function. And this rule applies to anything you do. If it's a cubic, you just cube how far you went. So if I count over 1, 2, 3, I square that, that's 9. 1, 2. And then of course I know there's 1 on this side. Does everybody see how easy that is to graph? You just start at that vertex, and however far you go over, you square that. Now, if there was a number out front, then you'd also square it and then multiply by a, but no stress graphing. Now, this one worked out nicely. It's very easy to see the intercepts. They were integers, weren't they? So our x-intercepts are at 0, 0, and 4, 0. Is there another way, if those had turned out to be integers? Can you think of another way? How else could I graph if I have vertex form? Well, the second way, you could FOIL and factor. Let's try that. So if I have this equation, right? I'm going to do that. What's x minus 2 squared? Well, x minus 2 times x minus 2 is what? X squared minus 4x plus 4, and then minus that 4 at the end. So it's x squared minus 4x. So I would say 0 equals x times x minus 4. And we have 0 and 4. Did we get the same answer? The other way, what would you do if you got to a problem and it didn't factor? Are you stuck? Never. Never on quadratics are you stuck, because there's one method that always works. And what is that? Quadratic formula. You have to FOIL first. Should we write the quadratic formula down? Do you know the quadratic formula? Because I expect you to know that. Let's write it down. X equals -b plus or minus b squared minus 4ac all over 2a. That works every time. There is no quadratic that doesn't work for. So that's your backup plan. If you can't factor, you can't get it to work out, go to your quadratic formula and you'll always get it. And a lot of our software will ask you to answer with an exact answer and a radical. That means you have to use the quadratic formula. They're not going to take a calculator decimal, right? Okay, y-intercept. What's the y-intercept on this? We can already see it. It's 0, 0. Axis of symmetry is always x equals, and then it's going to be the x of the vertex. So what is it? Right? This number and this number are always going to be the same. The domain, what's the domain for all quadratics? We know that. The range is going to be the bottom comma top. This bottom is at -4. It does touch -4. That's a comma, it doesn't look curvy. So is everything okay if we're in vertex form? You can find everything. You might have to distribute or FOIL and add the constant on, but we're good to go with that, right? Okay, example 2. Graph the following and then find all of its unique characteristics. What's bad about the way that one's written? Yeah, it's out of order, and that's bad. That could cause your eye to look and think that it's ABC. So if you get a parabola written and it's not in its correct order, fix it up. It will prevent you from making some little mistakes. Right? So which way does this one open? Down. If I'm in a hurry and I glance at this, I may look here at the 8 and say, oh, the front is positive. But we always have to look at the quadratic. Since it opens down, down looks like that, right? Will the vertex be a max or a min? It's going to be a maximum, right? Now, what is the vertex? This is not written in vertex form, so I can't see it. So we have to find it. How do we find the vertex? Negative b over 2a, right? That's the x part. Then we have to plug it in to find the y part. So if we plug that in, okay, so now we're going to plug in negative b over 2a. So something I like to do is make a conscious effort to identify a, b, and c. It's very easy to make a mistake if there's a minus and you forget to put it in. So let's identify. What is a? A is this, that's -1. See, by writing it down now, I'm not going to forget the negative. B is 2, C is 8. Make sure you know A, B, C. So the vertex is negative B. I just have to look negative B over 2A, right? And what is -2 over -2? It's -1. So now I have to plug -1 in. Oh yeah, +1, negative over negative. Now I have to plug that in here to figure out what's going on, right? So that's going to be 1 squared is 1, and I take the opposite. 2 times 1 is 2, plus 8. So what is that? -1 plus 2 plus 8, 9. There we go. We have the vertex. So I can graph that 1, 9. Now it opens down. What is the value of A? A is -1. That means coming down. So I'm going to count down, but it's not a stretch or a shrink, correct? So if I go over 1, I should square 1 to know how far to come down. 1 squared is 1. If I go over 2, 2 squared is 4. And of course, it's buy one, get one free, right? Because a parabola is symmetrical. And if I go back to the vertex and count 1, 2, 3, what's 3 squared? 9. So I'm right there, aren't I? So you can easily see where do we have the x-intercepts? 4 and -2. So 4, 0, -2, 0. What is the y-intercept? That's visible. We can see right there that it crosses at 8. And some of the software will allow you to just put a number, which really bothers me. I want you to know that an intercept is really a location, even if they let you just write the number. The axis of symmetry, okay, that's always going to be what? The x of the vertex, right? The domain is the same for all parabolas. And the range is bottom, comma, top. So the bottom goes down to -infinity, and the top is where? At 9. Okay, does that make sense? Is that good? All right, we're going to stop there.